Good morning friends. So I welcome you all for my online learning sessions. So in previous session we all know that we have discussed many things about matrices, right? With the same concept, with the same knowledge, let us proceed to today's session, right? We all know that we have started exercise 3.3, right? So we have also finished up to problem number 5 and some problems I have given as homework. I hope all of you have got the answers for that. They were very simple, right? So similar problems we have solved many in the examples, right? So up to 5 it is finished in exercise 3.3 according to your NCERT 12th mathematics textbook. So now let us start with the 6th problem. So in today's session let us begin with this 6th problem here. So what is the given here? If A is equal to, there are two sub questions in the 6th one. First one, if A is equal to cos alpha sin alpha minus sin alpha cos alpha, then we should verify A dash into A is equal to I. We should verify A dash into A is equal to I. Similarly, second question is also 2 cross 2 matrix, which is sin alpha, cos alpha, minus cos alpha and sin alpha. Here also we should verify A dash into A is equal to I. What is A dash? A is given, so we can get A dash. A dash is nothing but transpose of A, right? And we can multiply A dash with A. What is I? Identity matrix, right? I is what? Identity matrix, right? Okay. So what is identity matrix for multiplication? That is unit matrix, and its order will be equal to 2 cross 2. So this will be our required identity matrix, because the given matrices are of order 2 cross 2. So the required identity matrix also will be of the order 2 cross 2. Okay. So let us begin with the first one. Given A is equal to what? Cos alpha sin alpha minus sin alpha and once again cos alpha, right? So what will be A dash? That is transpose of A. We all know that transpose of a matrix is nothing but interchanging rows and columns. So first row let us write it as first column, second row let us write it as second column. First row what we have in cos alpha and sin alpha, that will be written in the first column, cos alpha and sin alpha. And in second row what do we have here? Minus sin alpha and cos alpha. So that should be written in second column, minus sin alpha and cos alpha. Is that clear? So first row in first column, second row in second column, right? This forms the transpose of the matrix A. Now A into A transpose, LHS is what? A into A transpose. A into A transpose is, what is A? It is given as cos alpha sin alpha minus sin alpha and cos alpha, right? So this is the given one. And what is A dash? A dash we have calculated or we have obtained here, that is cos alpha minus sin alpha and cos alpha. Is that clear, my students? Right? So A into A dash is what? A is here, A dash is here. Now let us simplify this. Okay. So what we will get? A into A dash. A into A dash is, see, multiplying two matrices. So multiplying means each row of first matrix should be multiplied with each column of the second matrix. So multiplying first row with first column, first row with first column. So first row with first column, what do we have here? Cos alpha into cos alpha, that will be cos square alpha. Is that correct? Cos alpha into cos alpha is cos square alpha. Now sin alpha into sin alpha. This will be plus sin square alpha. Is that clear? Cos alpha into cos alpha is cos square alpha plus sin alpha into sin alpha is sin square alpha. Now first row we have multiplied with first column. Let us multiply first row with second column. So cos alpha into minus sin alpha, that is minus sin alpha cos alpha, right? Cos alpha into minus sin alpha can be written as minus sin alpha into cos alpha or minus cos alpha into sin alpha. Now sin alpha into cos alpha. Right, that is sin alpha into cos alpha. Right, first row we have multiplied with first column and second column. Now let us multiply second row with first column. Second row with first column. If we multiply, what do we get? Minus sin alpha into cos alpha. That is minus sin alpha cos alpha plus cos alpha into sin alpha. Right, this is therein. This is what we get if we multiply second row with first column. Now let us multiply second row with second column. That will be our last operation. Second row with second column. So when I multiply second row with second column, minus sin alpha into minus sin alpha. What is the value? Minus into minus becomes plus. Sin alpha into sin alpha is sin square alpha. So it will be sin square alpha plus cos alpha into cos alpha. That will be cos square alpha. Fine. So a into a dash is the what? This is the value of a into a dash. Now if I simplify this, what do I get here? Cos square alpha plus sin square alpha, or sin square plus alpha plus cos square alpha. What is the standard identity? Sin square theta plus cos square theta is equal to 1. So this will be 1, and minus sin alpha cos alpha plus sin alpha cos alpha will cancel each other. So will be 0 here. Once again minus sin alpha cos alpha plus sin alpha cos alpha will get cancelled. So once again we will get 0 here, and once again the same story, sin square alpha plus cos square alpha is equal to 1. So we will get here. So this is the standard identity, that is sin square theta plus cos square theta is equal to 1. So sin square theta plus cos square theta is equal to 1. If we apply here, we will get 1 and 1 in this problem. Right? Then what is this? What we got here? The thing which we got here, what do we call for this matrix? This is a unit matrix. And unit matrix is nothing but identity matrix for multiplication. So this can be written as I. So this is how we need to prove A into A dash as equal to I. Is that clear? I hope that will be clear. And similarly, on the similar basis, you can prove A dash into A as I for the second one. So you try this for yourself. Okay. So try it. Okay. So you pause the video, take down the notes and try this second one by yourself. Okay. Fine. Take down the notes. So friends, I hope you have taken down the previous problem and also you got the answer for that second part, I hope. So let us proceed with the next problem, that is 7th one. So what is given here? Show that the matrix A, there is some matrix given over here which is the 3 cross 3 matrix. So we need to show that the matrix is symmetric matrix. And in second part also they are given a matrix A which is also a 3 cross 3 matrix. We should prove it as skew symmetric matrix. In first one, a 3 cross 3 matrix should be proven as symmetric matrix. In second one, 3 cross 3 matrix should be proven as skew symmetric matrix. Okay. So coming to symmetric and skew symmetric, already I have explained that one very clearly, but still once again I repeat, what is a symmetric matrix? If you take a transpose of this matrix, for example matrix A, if you take a transpose of this matrix, if nothing changes after taking transpose also, the transpose matrix and this original matrix, if they are same, then that particular matrix we can call it as symmetric matrix, right? So in second case, what is skew symmetric matrix? Once you take a transpose of this matrix, if you get negative of this one, the matrix which is transpose of this, or the transpose matrix which you have taken from this matrix, if it is negative of this matrix, then we call it as skew symmetric matrix. Okay, so let us start with the first one. What is there? A is equal to 1, minus 1, 5, minus 1, 2, 1, 5, 1, 3. Okay, so from this I can write A transpose as, what is transpose? Taking expressing rows as column and columns as row. First row to be expressed as first column. What we are having in first row? 1, minus 1, 5. So that will be in first column. Okay. So second row will come in second column. What are the elements in second row? Minus 1, 2, plus 1. So that will come in second column. Minus 1, 2, plus 1. And what is there? What is that we have in third row here? 5, 1, 3. That will come in third column. 5, 1, 3. So this is A transpose. This is given matrix A. This is transpose of that matrix A. Now check whether are they equal. Definitely, because first row 1, minus 1, 5. There also we have 1, minus 1, 5. In second row we have here minus 1, 2, 1. Right? There also minus 1, 2, 1. So from third row 5 and 3. Here also we have 5 and 3. So we can conclude that A dash is equal to A. So as A dash is equal to A is a symmetric matrix. Fine. A is a symmetric matrix. Right. So first part is proven. So let us move on to second one. What is the given matrix A? It is 0, 1, minus 1, minus 1, 0, 1, 1, minus 1, 0. Okay. What will be A transpose? Expressing once again rows as column. First row we have 0, 1, minus 1. So let it put it as first column 0, 1, minus 1. Second row we are having here minus 1, 0, 1. So let it write it as second column minus 1, 0, 1. And what is there in third column? Minus 1, 1, 0. Fine. So this is there in the third column. Minus 1, 1, 0. So this is A, this is A dash. Right. So from A we got the value of A dash. Now, what should be the condition for skew symmetric matrix? A dash should be negative of A. So from here it is obviously it is not equal to A. So let us try whether is it negative of A. So if we take minus sign outside, if I take negative sign outside, then all the values will become, if the positive values are there, they will become negative. If negative values are there, they will become positive. Because negative I have taken outside, sign will change inside the matrix. So if it is negative, it becomes positive. If it is positive, it becomes negative. First element. And that will be for each and every element. So first element here is 0. Whether it is plus 0 or minus 0, that doesn't matters. So let us write it as 0. Coming to minus 1. So minus 1 becomes plus 1. And here minus 1, once again it becomes plus 1. So here plus 1 is there, that becomes minus 1. 0 as it is. Plus 1, once again minus 1. Right? Now here what we are having, minus 1, that becomes plus 1. Plus 1 becomes minus 1 and 0 as it is. Okay? Sorry. So here third row we are having minus 1 minus 1 0. So that will come in the first column. There is a small change here. So 1 minus 1 0 is there. So this will be plus 1 minus 1 0. Right? So right, minus 1 0. So now as this is plus 1, this becomes minus 1. As this is minus 1, this becomes plus 1. Okay, that becomes plus 1. So now you can see here 0, 1, minus 1, minus 1, 0, 1, 1, minus 1, 0. That is equal to A. But what we have here? Minus sign. So this can be written as minus A. That can be written as what? Minus A. Therefore, A transpose is equal to minus A. As A transpose is equal to minus A is a skew symmetric matrix, right? As A dash is equal to minus A, right? So A is a skew symmetric matrix. So we were asked to prove that in first case A is a symmetric matrix. We have proven it. And in second case we were asked to prove that A is a skew symmetric matrix. That also we have proven. Okay. So now what you do, as usual, you pause this video for a moment and take down these notes. Okay. Pause this video. So friends, so I hope the previous problem was clear. So let us move on to next one, that is problem number 8. So what is there in this one? They have given a matrix A, which is a 2 cross 2 matrix, and they have asked us to verify two properties or two identities. What are they? A plus A transpose is a symmetric matrix. That is the first one. And what is second one? A minus A transpose is a skew symmetric matrix. Alright? A minus A transpose is a skew symmetric matrix. Observe here what they say, A plus A transpose is a symmetric matrix. We need to prove that A plus A transpose as symmetric matrix. So when A plus A transpose, they have asked us to prove that symmetric matrix, then definitely A plus A transpose is a matrix. Then only we can prove it as symmetric matrix. Similarly, A minus A transpose is also a matrix. Then only we can prove that as skew symmetric matrix. So A we are having, we can take A transpose. So once we take A transpose here, we should add them to get the first matrix. To get this matrix, right? To get this particular matrix, we should add A and A transpose. So whatever matrix we get, we should take transpose of that matrix, because we need to prove that obtained matrix is a symmetric. When a matrix will be symmetric? When it is equal to its transpose. If A plus A transpose is to be symmetric, then the matrix A plus A transpose should be equal to its transpose. Similarly, A minus A transpose will be a matrix. If it has to be a skew symmetric matrix, then it is to be negative of the transpose is to be negative of this obtained matrix. So we will check it out how it will be there. Okay. First one. What is A? 1, 5, 6, 7. What will be A transpose? Writing rows as column. 1, 5, first row, it will be written as first column. So second row will be written as second column. Right? So we got A transpose. What will be A plus A transpose? It will be 1, 5, 6, 7 plus 1, 6, 5, 7. So the value will come out to be 1 plus 1 is 2, 5 plus 6 is 11, 6 plus 5, once again 11, then 7 plus 7, 14. So A plus A transpose is what? 2, 11, 11, 14. Right? So what will be A plus A transpose whole transpose? Right? A plus A transpose whole transpose. A plus A transpose we know. So what is the transpose of this one? 2, first row as first column and second row as second column. Let this be equal to 1, this be equal to 2. So you can see equation 1 and 2 are equal. A plus A transpose is one matrix, right? Then its transpose of this matrix is also equal, right? So this is the original matrix, this is its transpose. Both are equal. Then we can say that this particular matrix is a symmetric matrix. Why? Because transpose of this matrix is equal to the same matrix here. So if you take transpose of this matrix, you will get the same matrix. So when it is possible? When this matrix is symmetric. If this matrix is symmetric, then only its transpose will be equal to this particular matrix. Right? You can see here first row 2, 11, 2, 11, second row 11, 14, 11, 14. So 1 and 2 are equal. So I can say that this is a symmetric matrix. A plus A transpose is symmetric matrix. Okay, fine. So first one is finished. Second one also we have to prove it on the same basis. Okay, what is there here? A minus A transpose. Right? We should find out A minus A transpose here. Let us find out its transpose. Already it is also for the same matrix. So A minus A transpose can be written as A is what? 1, 5, 6, 7 minus A transpose is 1, 6, 5, 7. Now A minus A transpose will be 1 minus 1 is what? 0. 5 minus 6 is minus 1. 6 minus 5 is plus 1. 7 minus 7 is 0. So what is the value of A minus A transpose? 0, minus 1, 1 and 0. Right? What will be, let this be equation 3. Right? What will be A minus A transpose whole transpose? Transpose of this matrix. So first row as first column, 0, minus 1. Second row as second column, 1 and 0. So let it mark it as equation 4. Right? So now you can see, okay, not this one, right? still we have to prove it as a skew symmetric matrix, we should prove it as negative, right? So if I take negative of this, if I take negative sign outside, 0 will be as it is, 0 only, because plus 0 and minus 0 both are one and the same. If negative is taken, all positive values inside the matrix becomes negative, negative value inside the matrix will become positive. So what we are having here? 1, so that becomes minus 1, and we are having here minus 1, that becomes plus 1, and 0 will be as it is, right? So what is this? A minus A transpose whole transpose. Fine, that is what? A minus A transpose whole transpose, and that is equal to what? Minus A, right? That is equal to what? Minus A, right? Sorry, not minus A. So let it be as equation 4 only. So from 3 and 4 I can write from 3 and 4 it can be written as, see, A minus A transpose, you can see is 0 minus 1, 0 minus 1, 1 0 1 0. The values inside the matrix here and here, the values inside the matrix of equation 3 and equation 4 are same, but what is the difference here? It is positive, it is negative. Is that clear? This is positive, this is negative. So A minus A transpose can be, that is whole transpose, can be written as minus of A minus A transpose, right? Therefore, as it is negative, I can write A minus A transpose is skew symmetric matrix. I can write it as skew symmetric matrix. Is that clear? So this is how we need to prove it is symmetric or skew symmetric matrix. Take down the pause this video and take down the notes. Okay. So friends, I think you got the answers for the previous sessions. You got all the things whatever we have solved in previous slide, right? So with that thing we'll proceed to next problem. That is, we need to find here half of A plus A dash and half of A minus A dash, and they have given us the matrix A. So with the help of this matrix we need to find half A plus A dash and half A minus A dash. So to find half A plus A dash we need A dash. So to find half A minus A dash also we need A dash. So with A, let us find the value of A dash. Okay. A is equal to what? 0, A, B, minus A, 0, C, minus B, minus C, 0. Right, this is our given matrix A. So what will be its A dash? A dash means writing rows as column or columns as row. So first row, let us write it as first column, 0 AB, so that will be 0 A B. Second row is minus A 0 C, so it will be minus A 0 C. And third row will be B minus C 0, so that will be, sorry, third row will be minus B minus C 0, so minus B minus C 0. See, first row is 0 AB, 0 AB, second row is minus A 0 C, minus A 0 C, third row minus B minus C 0, minus B minus C 0. Right, this is A dash. So first one, so what is A plus A dash? 0 A B minus A 0 C minus B minus C 0. This is A. plus what is A dash? It is here 0 minus A minus B, A 0 minus C, B C 0. Right? So this is what we got from A plus A dash. Right? What is this? 0 plus 0 is 0, A minus A, 0, B minus B, 0, minus A plus A, 0, 0 plus 0, 0, and C minus C, 0, minus B plus B, 0, minus C plus C, 0, and 0 plus 0 is 0. What is this? A plus A dash. Right? So now what we want here? Half of A plus A dash. Half of A plus A dash. There is half of, what is there inside? 0 0 0 0 0 0 0 0 0. This is what we have inside, right? So half of A plus A dash will be equal to half taken inside, it gets multiplied with each and every element. So each and every element here is 0. So 0 multiplied by anything will be 0. So this will be 0 0 0 0 0 0. So half when taken inside, it gets multiplied by each and every element. So 0 multiplied by half is always 0. So this will be 0. Right? So this is what we needed from first one. Right? So half of A plus A dash. So in the similar basis, you can try for second one also. Right? So you can try this second part as yourself. Right? Up to here, how to solve it, I have shown. Right? Only thing is you need to take negative of this, A minus A dash. Is that clear? Okay. Now pause this video, take down the notes and try this second part by yourself. Okay. So friends, let us start with the next problem. So there is 10th one. Express the following as sum of symmetric and skew symmetric matrices. So they have given us 4 set of matrices. So we need to express each one of them as symmetric and skew sum of symmetric and skew symmetric matrices. So how to do that? Okay, let's see it one by one. Let A is equal to 3, 5, 1, minus 1. So first one, we will take at this matrix as A. So let A is equal to 3, 5, 1, minus 1. Right? So now what will be A transpose? Three, 5, 1, minus 1. So A transpose will be 3, 5, 1, minus 1. That is 3, 1, 5, minus 1. Right? So this is what? A transpose. Okay? So now, how can we express A? A can be expressed as half A plus A transpose plus half A minus A transpose. Right? Okay? So we can express A as half A plus A transpose and half A minus A transpose. Right? So P is equal to half of A plus A transpose. Right? So that is nothing but half of, what is A? 3, 5, 1, minus 1 What is A transpose? 3, 1, 5, minus 1. Right? So this is nothing but half of, what is 3 plus 3? It is 6. 5 plus 1, that is also 6. 1 plus 5, 6. And minus 1, that is minus 2. So what we got here? A plus A transpose. Right? So there is half of A plus A transpose. Then what is P? Half taken inside. It will be 3, 3, 3 and minus 1. This will be our P. Okay. Let mark this equation as equation 1. Mark this one as equation 1. So we have calculated this part. Let us calculate this one. Right? A minus A transpose. Let Q is equal to half of A minus A transpose. What is A here? 3, 5, 1, minus 1. And what is A transpose? 3, 1, 5, minus 1. Okay. So what will be the value? 1 upon 2 times of 3 minus 3 is 0. 5 minus 1 is 4. 1 minus 5 is minus 4. And 1 minus of minus 1 is 0. So Q is what? See, it is half of this particular matrix. Take half inside. So each and every value will get divided by 2. So 0 divided by 2 is 0. Right? And 4 divided by 2 is 2. Then if you take this inside, minus 4 divided by 2 is minus 2. Then 1 upon 2 0 divided by 2 is 0. Right? This is what we get the value of Q. Okay. So now what they said, we should express this particular matrix as a sum of symmetric and skew symmetric matrix. Right? So from equation 1 we know that, from equation 1 what is A? A is half into this plus half into this. What is this part? Nothing but P. And what is that? Q. So from equation 1 we know that A is equal to P plus Q. So either P and Q should be symmetric and skew symmetric matrix. Right? So coming to P. What is P? P dash if you take? If I want to calculate P dash, what will be the value? Expressing rows as column. 3, 3 and this one 3 minus 1. This is equal to P. Right? So here P dash is equal to P. So therefore P is a symmetric matrix. P is what? Symmetric matrix. Right? Now Q. What is Q transpose? First row is first column and second row is second column. Right? So if I take negative sign there outside, if I take negative outside, positive becomes negative and negative becomes positive. 0 is what? Negative 0 or positive 0, it is 0 only. Minus 2 becomes plus 2, plus 2 becomes minus 2 and 0 as it is. Right? So this is nothing but minus Q. You can see here. Right? So 0, 2, minus 2, 0. That's the same thing there here, but with minus sign. So I can write q dash as what? Equal to minus q. As q dash is equal to minus q, so q is nothing but a skew symmetric matrix. Q dash is what? Skew symmetric matrix. So now we need to check whether they are, obviously it is there here from equation 1. We can say that A can be expressed as P plus Q, right, where P is a symmetric matrix and Q is a skew symmetric matrix. But still we need to check that whether if we substitute the values here, are we going to get back the equation, or are we going to get back the matrix A, right? So P plus Q, what you get? P is what? 3, 3, 3 minus 1, 3, 3, 3 minus 1 plus Q is what? 0, 2, minus 2 and 0, right? So P is what? 3, 3, 3 minus 1, and Q is what? 0, 2, minus 2, 0. So if I add them, what will I get? 3 plus 0, 3, and 3 plus 2, 5, then 3 minus 2, that is plus 1, and minus 1 plus 0, minus 1. So am I going to get back the value of A? Yes, definitely. It is what? 3, 5, 1, minus 1. So what we got here? 3, 5, 1 and minus 1. Right? So with this, we say that it is nothing but equal to what? A. So A is what? P plus Q. P is what? Symmetric matrix. Q is what? Skew symmetric matrix. So as A can be expressed as sum of P and Q, so it can be said that A can be expressed as sum of symmetric and skew symmetric matrix. Is that clear? So this is how we need to solve it. Same thing is applicable whether it is 3 cross 3 matrix or 2 cross 2 matrix. So remaining second, third and fourth, you try by yourself. Whatever answer you are getting, you comment me in the comment box. Wherever you face difficulty, feel free to express them. Right? So write them in the comment box. Definitely I will get back to you. Okay? So pause this video. Take this thing here. This is very important. You should be very careful and very slowly you go through my video. Alright? Then you will understand this thing. Okay? So now for this moment you pause this video and take the notes down. Second, third and fourth. Second part, third part and fourth part you try by yourself. It doesn't matter whether it is 3 cross 3 matrix or whether it is 2 cross 2 matrix. Alright? So the procedure remains same. So with this knowledge you can try these 3 things by yourself. Okay? So take it down. Okay friends, so I hope you have understood the previous problem there. So let us start with the next problem, right? So as we all know that last 1 or 2 problems from your each NCERT exercise will be on objective based. That is optional type. So these are the last 2 problems, 11th and 12th, right? So let us try to solve this. What is there here? If A and B are the symmetric matrices of same order, that means here the order is not mentioned but it will be same, right? Whatever order matrix A is having, same will be the order of matrix B. If A is 2 cross 2, B also will be 2 cross 2. If A is 3 cross 3, B also will be 3 cross 3, right? So whatever order is there, that will be the same order for A and B, right? Then AB minus BA is, see here, as they have mentioned that A and B are symmetric matrices of same order. Whenever it comes about symmetric, definitely it should be a square matrix. If they have not given this, then also it is a square matrix. If they have not mentioned symmetric matrix, then also these matrices will be square matrix. Why? Because they are of same order, right? So when matrices of same order, are there and they are eligible for multiplication, then definitely they will be a square matrices, right? Then only two matrices of same order can be multiplied. It is the only condition where same order matrix can be multiplied if they are square matrices. If they are not square matrices, same order matrices cannot be multiplied, right? So AB minus BA. So anyway they have given that it is a symmetric matrix. We should find the order of AB minus BA, right? So it is not of the order, sorry. We should find that which type of matrix they are. Whether they are skew symmetric matrix, whether they are symmetric matrix, whether zero or identity matrix, right? So for either for symmetric or skew symmetric, we should verify it with its A dash. Let's try with the transpose of the given matrix. AB minus BA will be a matrix. Remember this one. If you multiply A and B, that will be a matrix. If you multiply B and A, that also will be a matrix. If you take difference of AB and BA, that also will be a matrix. And that matrix, if it is skew symmetric, it should be negative of its transpose. If it is symmetric, it should be equal to its transpose, right? If it is zero matrix, all the values should be zero. If it is identity matrix, so it should have 1 1 1 along the diagonal. Okay, so let us try these two things first. Consider, let us check for skew symmetric matrix or symmetric matrix. If it is skew symmetric or symmetric, we should take its transpose, right? Given matrix is what? AB minus BA. Here as the matrices are not known, A and B are not known to us, so it is not possible to calculate the value of AB and BA. Keep it as it is. Take its transpose. I can write AB minus BA transpose as AB transpose minus BA transpose. Why? Because A minus B transpose is equal to A transpose minus B transpose, right? A minus B whole transpose can be written as A transpose minus B transpose. Now this one, what is AB whole transpose? See, from this step we have written this one. AB minus BA whole transpose is equal to AB transpose minus BA transpose. Now what is AB whole transpose? I can write this as B transpose into A transpose minus, what is BA whole transpose? I can write it as A transpose into B transpose, because AB whole transpose is B transpose into A transpose. This is the identity. It is the identity. AB whole transpose can be written as B transpose into A transpose, and BA whole transpose can be written as A transpose into B transpose, right? So now, as they are symmetric matrices, right? As they are symmetric matrices, right? What is the symmetric matrix? Its transpose is equal to itself. If A is a matrix, if A is a symmetric matrix, then A will be equal to A transpose, right? So A and B are symmetric matrix, so A transpose will be equal to A and B transpose will be equal to B. Why? Because they are symmetric matrix. Now A transpose is equal to A and B transpose is equal to B. Here I am having B transpose, I will write it as B. Here I am having A transpose, I can write it as A. Right? Why? Because B transpose is what? B. So instead of B transpose I will write B. And what is A transpose? A. Instead of A transpose I will write it as A. And here once again A transpose written as A and B transpose written as B. So this is BA minus AB. Don't cancel them. Here BA is not equal to AB. Here BA is not equal to AB because they are matrix multiplication. Don't cancel them. Right? So if I take this outside, this negative sign outside, inside what happens? Positive becomes negative, negative becomes positive, or this gets reversed. AB minus BA. This gets reversed. AB minus BA. Fine. So I can write minus BA whole transpose is equal to what we got? Minus of AB minus BA. We can write it as AB minus BA. See, transpose is negative of its value, right? So when A transpose is equal to minus A, then A is which type of matrix? Skew symmetric matrix. When A transpose is equal to minus A, we can call A as skew symmetric matrix. Now AB minus BA whole transpose is minus of AB minus BA. So transpose of this matrix is negative of this matrix here. You can see here also we are having AB minus BA. Here also we are having AB minus BA. But what is the difference? Negative. So as the transpose of this matrix is negative of this matrix only, so we can call this particular matrix AB minus BA as skew symmetric matrix. AB minus BA is called as what? Skew symmetric matrix. If this negative sign is not there, then that would be the case of symmetric matrix. Is that clear? So I hope this problem is very much clear. So if you have not understood this one, or if it is confusing, go through it very slowly. It is very easy actually. Go through it very slowly. If ever you get any doubt, you can comment me. Okay. So coming to next one, there is the last problem of this exercise. If A is equal to cos alpha minus sin alpha cos alpha, then A plus A transpose is equal to what? I. Then A plus A transpose is equal to I. Then what is the value of alpha? Right? So for what value of alpha, A plus A transpose will be equal to I. Okay? A is what? Cos alpha minus sin alpha cos alpha. A transpose will be writing rows as column. First row will write it as first column. Cos alpha minus sin alpha. Right? Now second row as second column. Sin alpha cos alpha. Okay? So we have A, we have taken A transpose. Now given condition is what? A plus A transpose is equal to I. But what is A plus A transpose? Cos alpha minus sin alpha cos alpha plus A transpose is what? Cos alpha sin alpha minus sin alpha and cos alpha. This is A plus A transpose, and that is equal to what? I. Will be equal to I. If you add this, what will be A plus A transpose? Addition of these two matrices. If I add, what will I get? Cos alpha plus cos alpha is 2 cos alpha. Minus sin alpha plus sin alpha is 0. Sin alpha minus sin alpha is also 0. Cos alpha plus cos alpha is 2 cos alpha. This is equal to I. What is I here? 1 0 0 1. I is the identity matrix. There is nothing but equal to 1 0 0 1. Now these two matrices are equal. When any matrix will be equal? When their corresponding elements are equal. So I can equate the corresponding elements. So 2 cos alpha will be equal to 1. By equating corresponding elements, what will I get? 2 cos alpha is equal to 1. If I take 2 on the other side, what will be what I will be getting? Value of cos alpha. That will be equal to 1 I am having in the RHS, 2 coming here. So it will be 1 by 2. So when cos alpha is equal to, the value here is what? Cos alpha is equal to 1 by 2. So when will be cos alpha 1 by 2? Right? When alpha is equal to pi by 3. What is cos pi by 3? 1 by 2. So cos alpha will be equal to 1 by 2 when alpha is equal to pi by 3. Or this 1 by 2 is the value of cos pi by 3. What is cos pi by 3? That is equal to 1 by 2. So I can replace this 1 by 2 as cos pi by 3. Right? So cos alpha is equal to cos pi by 3. Cos alpha is equal to what? Cos pi by 3. Now cos and cos cancels on both sides, or alpha value will be equal to pi by 3. So what is the value of alpha? That is nothing but equal to pi by 3. That is option B. Right? I hope this problem is very much clear. So once again I repeat the same, I give the same instruction. Wherever you are not understanding the kind of things, you try to view them once again slowly by paying lot of attention, then definitely the things will be clear. If after that also, if the things are not clear, you can comment me your doubts in the comment box, so I'll get back to you. Okay? And whatever problem I have left for you yourself to solve, you solve them and comment the answers on the comment box. Okay? So we'll stop here. By this exercise is also finished. Third exercise is also finished. So we are going to stop here. So next topics, that is related to inverse of a matrix and related to row and column transformations, everything we will see in the next class. Okay, that is the next session. So we'll wind up this session here, right? So you pause the video for a moment and take down the notes. Okay, thank you.